Y'all know Reverb.com, the gear acquisition mecca. Today's a very fun video when we're gonna connect to its API and draw data from it. I promise you it's as fun as it sounds. I have to get it off my chest because I can't proceed with the analysis unless I tell you how I got the data. Oh, and by the way, the API is an application programming interface. It's the language your application or your code communicates in with Reverb.com or any other resource you're requesting to. It's the link between the two. It's the rules of communication between them. We're going to be using a Python notebook. I wrote all of the code myself and I'll share the codebook with you. The plan for today is get familiar with the manuals, connect to the API, download the data, process it so that it's analyzable, and then call it a day. And by the way, I'm Vadusha and I'm the greatest expert in programming, machine learning, and data analysis in the entire world, and maybe, I say maybe, even on YouTube. Ultimate goal is to make a model that could predict the pricing at Reverb.com based off item parameters like guitar colors, type of products, guitar brands, and ages and whatnot. But before we get to the analysis, we need to subscribe to the channel. We need to collect the data. I got myself familiar with Reverb.com's API. I saved my token to a variable, and there's a URL we're going to be requesting to. It says page 54, which is a random page. It has no meaning. We feed the token. The manual also said to include the version. No idea what this does. Send a request, get a response, save it to a variable, convert it to a JSON so that it's readable. It says that we have a total of almost 400k data points. We're on page 54, which we actually requested. That's nice. It does what we're telling it to. I love it. The total pages is 50, per page is 24, which to me sounds like bad maths. If you multiply this by this, you get this, not this. That's technical data. The actual listings are the items on Reverb. And the first one is a make noise module black. What is that? Let's Google it. It's a synth module. We don't care for synth modules. We need to find a way to request guitar related information. We don't care for them synths. We get the make, we get the model, we get the finish, we get the year, title. This to me looks like some analyzable information. We can pull some meaningful data from there, but it bugs me that the total pages is 50. Let's request a page above 50. Say 540. How about that? It returns page 540 out of 50, which is still bad maths. Reverb.com, what? Tom Anderson, drop top, Cajun Magent with binding. What? Looks like it's a dozen different guitars. Maybe a guitar there. If your Reverb.com listing needs Googling to find what item it is, the wording is not good. I mean, improve your wording if it's like this, please. The total number of items is still around, it's the same, almost 500,000. What if we go crazy, like 800 pages? How about that? Still returns something. So what I found, what we're sending to the API is a web page address like search request, and the returned search results cannot exceed 20k listings for some reason. I messaged Reverb.com and they confirmed my suspicions. I also asked the guys if I could do the whole research thing and got an okay from them. Networking. How about we convert the data into a table format and see it like it's a data frame? So we have a list of makes, Harley Benton there, tremolo, Harley Benton tremolo, nice, great naming, Gibson, classic Les Paul, Honeyburst, pretty recent. There's some additional information there. This does look like some analyzable, very much usable information. But the problem is we still have to send search requests that don't exceed 20,000 items as results. So what I think is we need to find a way to narrow down the search so that it says guitar, which narrows down the results a little bit. Then say, give it a price range, like guitar, $10. Then guitar, $10 to $20. Then guitar, $20 to $30. And go all the way up to say $10,000. Iterate it through every single range of $10. I'm pretty sure that each of the instances will return a list of results that's shorter than 20,000. We're not going to be doing this manually. We're going to write a function to do it for us. Call the function extract data, because we're going to be extracting data. Product type, by default, it's electric guitars. We'll also add bass guitars and acoustic guitars, because having just electric guitars is boring. Let's set up a list to record the responses in it and then convert it to a data frame. Am I making it interesting enough? Start with page 1 and then set a dummy page somewhere way up above, and we'll return the maximum page number from the query. Items per page, we previously used 24. I empirically found the maximum is 50. While page, this one, is less or equal than total pages. So unless we reach the end end of the pages. Keep requesting. Page number here, per page, set by default. Product type, electric guitar by default. Price minimum, we'll see about that later on. Price maximum, we'll see about that later on. We'll write a separate function to iterate through price ranges. Headers, we get the my token thing. I registered at reverb.com API and got myself a token. Get yourself a token. And by no means this is sponsored. Nobody paid me to do this video. It's just for funsies. And if the response returns an error, so the code ain't 200, it should break the function. Record the data, extract the current page number, extract the number of pages from the returned JSON, then append the response to our initially created list of responses here. We imported the cache, otherwise every iteration, every time I run the notebook, would take another 5 or 7 hours. We don't want that. This is a sleep timer. Unless the response has been cached before, let it sleep for 0.15 seconds so that we don't overflood the API with requests and they don't ban us. When we're done, increment the page. When everything is done, we get a list of data frames, concatenate the data frames, and return the results. That's the way we're going to be getting our data. I'm pretty sure there's an easier way, but that's the only way I know how to do it. If you know a different way, let me know in the comments, please. Let's test it. Set price minimum at 100, price maximum 105, and extract data with these parameters. It'll set product type to electric guitars by default. And that's the result. There's a you rock. How does it know that? You totally do. It's a MIDI controller. All right, a bunch of guitar-related information. A total of almost 150 rows. Okay, we like it. Let's write a function to iterate through price ranges. The name has to say it all. Category, electric guitars by default. Iterations list, keep it in the list. For every price. By that, we mean for every instance of minimum price. So that's the bottom threshold for the pricing. Ranging from 0 to 10,000 with an increment of 10. So 10 bucks a step. Every search result will return us electric guitars within a range of $10. Iterating the range by $10. So when we reach 10,000, we'll change the maximum price not by the increment, but up to the sky. Otherwise, the maximum price is just the minimum price plus 10. And that will make the function iterate through the extract data for every slot in the price range, feeding the minimum and the maximum prices in it and the category. And keep the data frames in a list, then concatenate the lists into a huge data frame and return the resulting data frame. And I'm hoping we're going to get a huge table containing all the data we need. So what we're going to do next is to iterate through the 3 categories we need. These are electric guitars, bass guitars, and acoustic guitars. The 3 things that are the most valuable in the world. The rest we don't care about. Fish, get out. We need electric guitars. This works pretty much the same way as the previous functions. It iterates through each category, applying this function, which in turn applies the previous function. We also concatenate the data frames and return the huge resulting data frame. It took me like a couple of days to come up with these things, so either the subject is very difficult or I am very stupid. But anyways, I found the workaround, I got the data, and we have somewhat around 400,000 data points. That seems a bit too much given the entire database is 495,000 data points. And I'm pretty sure when you search for electric guitars, bass guitars, and acoustic guitars and jam the whole thing together, there's going to be a bunch of duplicates. So we clear the data frame of those duplicates, and now we have 360,000 results. That's more like it. And if we run through the list of columns, there's the ID, which is a unique identifier for the listing, which will be useful for keeping the unique entries. Make, the model, the finish, the year, the title, some conditions, the description, price. So I studied the columns, and there's a list of descriptions if you need. You can open the code book and read through the descriptions, but we still can't analyze the data because it's all over the place. There's dictionaries within dictionaries. These are not very much analyzable. We're gonna prepare the data. That's the data preparation stage of data science, the most interesting and exciting thing ever in analytics. Stay with me and I'll show you what it is. We'll delete some of the items. I pointed out the ones I need to delete, and I marked in yellow what we need to process. First goes the year. We'll keep ID, model as they are, and we'll have to review the year because it's all over the place. Here's a list of unique values for the years. See, sometimes it's just the year, and that's what we need exactly. That can help us build a time scale and then put the data points on the time scale and see if the price prices are affected by what year the musical instrument was produced in. There's the NAs, 2000s with an apostrophe, this kind of thing. Then there's this 2020-ish, unknown era, new old stock. Huh? That new old stock. Many. Fits all. I totally want a guitar that fits all years. This is my fits all years Gibson Les Paul Sunburst. Alright, so we need to sift through that and make it look like this. This is a perfect way of putting in those years. We need a function that has regular expressions that processes those years and pulls the year information out from them. I'm not very good at natural language processing. I have no idea how this is done. So I had to do some regular expressions. I googled that. I don't really know regular expressions. And we're checking if the string, this thing, if it has certain format in it, and then pull it and convert it to a year format, a 4-digit format. When we run the function and then filter out those that have integer years, we'll see what's left over. Well, we filtered out NA, VTG, what? Vintage, I guess? NC, what? Les Paul wiring kit. That's the best year. I mean, buy guitars from the Les Paul wiring kit year. 2-year, vintage style, 2000s, unknown, brand new, UK, satin sonic blue. That's nice. Undetermined. So I guess we filtered it all right. The function worked. So we delete the data points that have those stupid years. The next one we're going to be dealing is the listing title, the actual title of the item. What you see when you search, and there's a list and there's the listing title. This should tell you what the product is, what the guitar is. It normally contains the make, the model, the year, everything is pulled there. It's descriptive and it's the way for you to understand if you found the right listing or not. There may be some useful information, but as I've said, I have no idea how natural language processing works. We'll use maths instead and find the length of the listing title. I guess price can depend on the length of the listing title. I'm pretty sure this information is going to be useless in terms of modeling, but we'll keep it just in case there's any correlations to the title length. Who knows? So that's pretty simple. We just apply the lambda function of the length of the string and rewrite the contents of the column, and then rename the column to title length instead of the title. That's it. Ain't it fun? We'll do the same for item description. Descriptions are normally very long. That's large text. That's everything. You describe the specifications, your thoughts on the product. The contents of the listing is the description. We'll use the length as well and see if wordier listings are more expensive than less wordy listings. Who knows? Next one is conditions. Conditions are fun, and I'm pretty sure they're gonna influence the pricing, because the better condition the guitar is in, the more expensive it is. I'm pretty sure the guitar made in the same year, of the same make, of the same brand, in different conditions, like in poor condition and in mint condition, will cost very, very differently. So there's a list of conditions. I copied it from Reverb's manual. So non-functioning, poor, fair, good, very good, excellent, mint, B stock, and brand new. What I want to do is to assign a rank to every condition. The higher the rank, the better the condition. So 1 will be non-functioning, like destroyed. Why would you sell a non-functioning something? I went 1, 2, 3, 4, 5, 6, 7, and then mint with inventory. The funny thing is, the search results don't have the mint with inventory condition. There's just the mint condition. And there's the with inventory column, which is separate, and it's true or false. So we're gonna assign 7 to both of these. And B stock is when a store sells an item and then the item is returned for some reason. And that's B stock. For example, the customer didn't like the color or something. Basically, brand new, but never used, returned to the store. That's B stock. And then there's brand new, which is a thing they sell as well. And we just map the conditions. So we'll have the column with condition names and the column with condition numbers. Then we have the price column, and it's a dictionary of prices hidden within a column. So we'll have to pull the price out of the dictionary, apply a function that pulls the amount information as floating point data, and rewrite the price column with it. And it's all in US dollars because our initial request had a US dollar mark in it. So it all got converted into US dollars. It's very convenient so that we don't have to make currency adjustments, currency conversions all over the place. This gives us around 300 listings. Next one is the category ID. I wonder what the UUID stands for. Unique ID, very much. Hey Reverb, is it very unique? Unique. And there's actually an API request that can return us the actual list of categories. We do that, there's the categories. Accessories, amp covers, banjo strings, bass cases, bass gig bags, bass strings, books. You get the idea. The ones we need are acoustic guitars, bass guitar, acoustic bass guitar, electric guitars. So we make a list of those containing the ID so that we don't mess the wording here, and then filter everything so that all we have are these categories, nothing else. No accessories, no guitar parts, no cables, no nothing, just guitars. It gives us 56,000. That's not all that much. Remember, we had over 400,000 and it like went down 4 times. Our big data is getting smaller and smaller. Sad times. Then there's the published at column, which is easy. We'll just convert it to the date time format. That's it. Next one is the state, which I guess is whether the listing is live or not. So we'll filter anything that's not live. It went down 1 line. Was it worth the effort? Yes, it was. Then there was the list of columns we did need, so drop them. The finish, who cares? There's too many options in the finish. We can't narrow it down to a list of discrete categories. Created at, shop name, condition ID, boil price, you get the idea. We'll kill all these. And we have this neat little table. Okay, we got strings in here. Guitar tuners. Oh man. I was hoping we would get a clean database. This gave us a contaminated database. We have all of those Allen keys and guitar tuners and strings in here. I'm pretty sure there's cables and capos and guitar cases and amps and everything. You can't label a guitar amp a guitar because it's guitar related, but those who do will burn in hell. So we have this make, and this does not look like make. I'm pretty sure we can filter the make column to make it cleaner. There's 57 unbranded things. We don't care for unbranded lines. Kill them. I manually ran through the list of makes and I found some of them are not what we need. There's the compatible, like guitar compatible. If it's guitar compatible, it's most likely not a guitar. So tuners, 4 electric guitars, custom pickguards is not a guitar make at all. There's the list. Boss doesn't make guitars. Line 6 is processors and amps. EMG pickups, no guitars. Marshall doesn't make guitar. You get the idea. We get rid of those makes, narrowing down the list a bit. If the function finds any of these words in the make string, it eliminates the line. A bit over 4,000 unique entries. Another thing I did that took about a couple of hours is to look through the list and find anything below 100 that is a guitar. So these are guitars, those IDs, so keeping them. There's some more junk information in that. I wish I knew the natural language processing algorithms. If you can teach me, let me know please. I found that these words normally trigger a warning. I'll filter the entire data frame, but I'll not be removing the lines. Instead, I'll look through them manually and see if it's a false flag or it's not. This should be enough information for me to figure out whether it's a guitar or not. This seems a guitar. These are guitars. And I found that there's a list of words that normally means it's a guitar. Like it's a with, W, that means a guitar with case. And there's a bunch of ways to write with. And there's like the parlor guitar, dreadnoughts, concert guitars, baritones, resonators, cutaways, campfire guitar, folk guitars, hollow body, gypsy style guitar, fast neck guitars, double neck, round neck, square neck. You get the idea. Removing these from the list because it's too much to go through. It took me about 2 hours, and these are the IDs I want to remove. These are either amps or guitar cables or guitar straps or accessories or guitar parts, pickups, nuts and bolts and knobs and everything. So removing these, and all we have left is the guitars. It does look like that's a good guess at a guitar list. And that's the data we're going to be analyzing in the next video. Please do subscribe to the channel to not miss the next video. This was fun, wasn't it? Like the video if you liked the video. If you didn't, still like the video. Go check out the code book, see if you find some other ways to download data that are more efficient than this. Go study data science. Data science is fun, and I'm pretty sure you're gonna succeed in it because you're awesome. Yes, you are.